Here's another Hickok tube tester. This is the model 6000, and it's got the plug-in module. This happens to be the module for the older tubes, which is good because that's mostly what I'm working on, old pre-World War II vintage stuff. This I picked up as part of a estate sale. I recently bought a bunch of audio equipment, and this came with it. It didn't have the top, but the tester does work. I have plugged it in, and I can do the line test, and it centers properly. And I started doing some of the calibration procedure, which I have here for the 6000, and it's out of calibration, of course, but it seems to be working. I went through the filament test, and all the filament taps are working right. The roll chart is kind of stuck, and it's shifted over this way, so I need to take that apart and see what's going on there, do a cleanup, and then start a calibration. I'm still just cleaning up the face. It was without the top on it. This surface has gotten pretty dirty, but it's cleaning up okay. I'll go ahead and pull it apart, and we'll start calibrating it so we get it up to snuff. Before we get to working on the tube tester, today's IPA is this Devil's Backbone 8-point IPA. This is kind of a local beer from Virginia. It's kind of my go-to. You can pick this up at any grocery store around here. But it's a pretty good one, and it's not too expensive, so I'd recommend it. Alright, on to the tube tester. First thing I thought I'd do is remove these two screws from the plug-in module. Go ahead and remove that. And I cleaned this up down here and sprayed some deoxit down into the connector here just to clean that up, and then plug this in several times. And also removed these were set too low when they were touching, so I undid the set screw and lifted them up just a little bit so that it wouldn't touch the faceplate here. Now I did drop one of the little captive nuts, so I'm going to pull this apart, go fetch that so I can put the little plug-in module back on. I'll probably do that now. Alright, got it out and flipped around. The 6000 really seems to be pretty similar to the 600. It's got a 83 tube here and a 5Y3 GT. I'll go ahead and pull those and test them on the 600A here. Make sure they're good. And the roll chart seems to be way too loose. So I don't know if it's broken off at one end or the other, or just maladjusted. So I'll go ahead and pull it out and see if I can get it straightened out. We'll start there. 83 tube. It's good. That's half of it. That's the other half. So both sides of that are good. Let's try the other one. And the 5Y3. That half of it is good. And so is that half. Alright. So far so good. Okay, I got the roll chart working. Now these things are a bit of a pain. Usually what I find is that if you just lubricate the axles a little bit right here on both ends, it'll get them working. This one was kind of not attached real well on one end, so I retaped that. But you can see this is a direct drive mechanism. It drives both axles at the same rate. So as you wind up on one side, it gets bigger, and the small one's going to turn faster than the big one. So there's no real mechanism to adjust for that. So what happens when you get it in the middle, kind of like it is right now, it kind of, you can see as you roll it one way, it kind of gets big before it takes over and starts pulling it up. That seems to be the way it works, and then it gets real tight at one end and the other, and That's kind of typical of how these things work. So my objective usually is just to get them turning. I try to not rely on them. I'll go ahead and print out, test the data here in a sheet and use this to actually program the machine. And this is just having this thing work. It's just for the fun of it. It is kind of cool the way it rolls by. So that seems to be working. Tubes are good. I'm gonna probably pull the roll chart back off and deoxit all these controls. May replace some of these old vintage capacitors here. There's just a couple of them, one here and one there. And then we'll start the calibration. Alright, to get this thing up to snuff again, I've already replaced the two capacitors here, the electrolytic and the 0.5 microfarad right there. So pull the tubes and the chart, and I'm going to go ahead and deoxit all of the switches here, the rotary switches and the push button switches and the pots that I can get to. And I've started, I've got a calibration procedure here, originally one from the factory plus one that's posted online with what's this tube sound? Let me just scroll the top here. Yeah, tube sound. So it's pretty complete. I'd recommend going to that if you want to calibrate one of these. And I'm not going to show the whole calibration because there's already a couple of good videos online of a pretty complete calibration of the 6000. So this is just showing you how to clean one up and get it working. Alright, got this 6000A fully calibrated, as close as I can get. Got all the voltages correct inside the box. Put the roll chart back in. And I've got it set up right now to test a 12AU7, which is a fairly new tube. So it should read close to 2200 GM. Now I've got this set up to test with it on the 3000 scale dot. So it should read directly in GM on the top scale here. So when I press test, so it's reading, what is that, 2250. Okay, so what I'll do is just take this and plug it in over here on my 600A, which is also set up to test the same tube. Let's check the line here. It looks good. Give us a couple seconds to warm up. And this is also set on the dot for the 3000 scale. It's called English on this one here. It's called shunt on the 6000. They changed the name, but it's the same thing. Okay, so with this one, it reads, let's see, 22, 24, or 21 to 2250. Exactly the same. Now that's normally not the case. I think it just happened to luck out on this particular tube. A lot of times they'll vary quite a bit between the two different types of tube testers, or even the exact same model. I've got another one of these 600As, and many times they don't test that close together. But usually on the 3000 scale they're pretty accurate by using the dots. Now the dots for the 6000 scale and the 1500 scale a lot of times won't line up. So what I'll do is take a known good tube, or one that I know the GM on, and then figure out that well, for 6000 it needs to be on 86 instead of what this says, 87. And for this one I did the same thing, and for the 6000 scale it should be on 88, and for the 1500 scale it should be on 93 instead of whatever it says here, 92. So it's one or two off. So that gets you a little bit more accuracy, but really these things are really designed to be more of a go no go, not a laboratory instrument. Just, is a tube good or is it bad? And they're also good for, you know, telling the you know, difference between the two. If it's a dual tube like this one, there's two triodes in there. You can get the GM for both triodes and see if it's a well matched, or between multiple tubes on one machine, you know, how well they might be matched for transconductance. But yeah, definitely not a laboratory instrument or super accurate, but they do a good job for just testing. So this one's all done. I'm going to go ahead and put it into service along with my other Hickocks, and I'll do it on the video.